In this video, I will work on the homework that follows the lecture 0.4.3 on implicit differentiation. And as always, I hope you watched the this quick refresher on implicit differentiation. And let's jump right into the homework and see what type of problems are there. And real quick, the idea of implicit differentiation is very simple. It basically says if two functions are the same, then their derivatives must be the same. And this simple idea allows us to find derivatives of functions that are defined implicitly. And this process is called implicit differentiation. So in this case, we have a function defined implicitly, and how do we know it's a function? Although we're not concerned with that question in this particular setup, but in general, if you are curious how's this a function, type this equation in Desmos, and you will see that it will produce a relation whose graph passes the vertical line test, and therefore it is a function. And in this particular case, we're looking at the graph around the point 2, -1. And we should be able to see that that point does belong to the graph right there. So the question is, what's the slope of the tangent line? And again, intuitively we understand what the question is asking. We have some sort of tangent line, and for different values of m, it's gonna produce different slope, right? So if you were to guess which of this is the right answer, so if we were just to guess it, then I would guess it's about -4. Well, maybe it's -4, right? So again, intuitively we know what the answer should be, but analytically, how do we approach this problem? Well, we have to find the derivative. So we have to find y prime and evaluate it at when x equals 2. That's the task. And to find the derivative of this function defined implicitly, we simply are going to treat both sides of this equation or definition of implicit function as functions, and we're going to differentiate both sides and follow the rules of differentiation. So on the right side we have 0. On the left side we now have derivative of some linear combination of many functions, and we can apply the linearity rule first. So it's going to be -5x to the 4 minus 3y to the 5th, derivative of that. So we can take out that 3, derivative of 7x is 7, and derivative of y is, for now, let's just write it like this. So the idea is that since we don't know exactly what y is, we cannot find its derivative. So, but we can find derivative of -x to the 5th. So if I were to actually, if I wanted to be thorough here, I would have written it like this. We're looking at the derivative of x to the 5th. We're looking at derivative of x, and derivative of x to the 5th is 5x to the 4. Derivative of 7x is just 7. Derivative of y, we don't know, so we're just going to write it y prime. Derivative of -13 is actually 0. And derivative of y to the fifth is, to find derivative of y to the fifth, we have to acknowledge that we actually have two functions here. The raising to the power of 5 on the outside and the function y itself on the inside. So by the chain rule, it will be 5y to the 4 times y prime. And this is exactly what we're going to write here. 5y to the power of 4 times y prime. And in this case, again, remember the goal is to find y prime when x is equal to 2 and y is equal to -1. So if we were to actually just find the y prime, then we would have to isolate it. But in this case, we don't have to isolate it. We can just plug in x equals 2 and y equals -1. And when we do that, we pretty much know everything except y prime. So what we will end up with is an equation in terms of y. So we have -17 y prime is equal to 73. So y prime is equal to 73 over 17. So it's not quite 4. It's actually more accurate answer. So the answer is -73 over 17. That's not something that we would have guessed from the picture, but again, intuitively we knew that the answer will be approximately -4. So let's enter the answer, -73 over 17, and once again we found this using implicit differentiation. Now if you notice here, in this problem, in the solution by Newton, they actually isolate y prime first, but when you're actually looking for the value of y prime at some point, this step is not necessary. We can just plug in the values of x and y right into this, or rather even this equation right there. Alright, so next we're going to try to find the second derivative using implicit differentiation. And let's start by writing out the equation that defines the function implicitly. So we're going to differentiate both sides. On the right side we get 0 immediately. On the left side we have -27x squared minus, and now here I'm going to use the chain rule. So 3 times 3 is 9, y squared times y prime. And from here we're going to do two things. We're going to first isolate y prime. So we're going to do it by adding 27x squared to both sides. So -9y squared y prime is equal to 27x squared, and therefore y prime is equal to 27x squared over -9y squared, and we can reduce by 9, so it's -3x squared over y squared. That's the first thing we're going to do. And the second thing we're going to do, so this gives us the expression for y prime, and the second thing we're going to do is we're going to differentiate this again. So I'm going to copy this over. Remember, we're looking for y double prime, and one way or another we have to differentiate it twice. So let's take derivative again. On the left side we have -54x, and here, well, on the right side we get 0, and on the left side we have a product, so let's take out 9, and derivative of y squared times y prime will be derivative of y squared, which is 2y times y prime times y prime plus y squared times y double prime. But y prime we can replace with this. So finally we have negative 54x minus 9. Here we have 2y y prime squared, so we have negative 3x squared over y squared squared plus y squared times y double prime, and all that must be equal to 0. And we just need to isolate y double prime, so we're going to add 54x to both sides, divided by 18, and so let's do one step at a time. Adding 54x, and let's simplify this. So as we squaring, we have 2 times 9, 18. In the numerator we have x to the power 4. In the denominator we have y to the 4, but we also have 1y over there, so it's y cubed. Here we have y squared times y double prime, and all that is equal to 54x. We can divide it by negative 9, and then we subtract from both sides the 18x to the 4 over y cubed, and now we just divide it by y squared both sides. So y double prime is equal to negative 6x over y squared minus 18x to the 4 over y to the 5. And as far as I know, this is not unique, because y prime can be expressed in terms of y could be expressed in terms of y in more than one way. So hopefully Newton accounts for that non-uniqueness. So let's see. Yep, we got it right. Although they definitely got an easy answer here, right? So this is what I was saying about non-uniqueness. So their version somehow is easier than ours. How so? I guess maybe it was a little wasteful here to actually, the step where I found the derivative. Should have just continued and differentiated this equation the second time. But anyway, like I said, doesn't matter how you do it, you will get the right answer. So let's continue. Oh, here's our chance to do it the easy way. Let's try. So we're going to differentiate it. On the left side we have 14x minus 6y y prime, all that equals 0. We have 6y y prime equals 14x. We have y prime equals 7x over 3y, and we're going to differentiate this the second time. And on the left side we have y double prime, and on the right side we're going to use the quotient rule, so derivative of the numerator times the denominator minus derivative of the denominator times the numerator, all that divided by here I should put 3y prime over here, and here I should put 9y squared. So as expected, the second derivative depends on the first derivative, and we just need to plug in 7x over 3y instead of the first derivative, which we had found earlier. So the final answer will be 21y minus 21x y prime, but y prime is 7x over 3y, and all that divided by 9y squared. Looks like we can simplify it a bit further. So let's find the common denominator, 3. So we multiply this by 3. So first of all, I want to reduce everything by 3. So kind of, well, this becomes 7. So we don't need, so we only have y. So if I throw another y here, this becomes squared. So now we have 21y squared minus 49x squared divided by y, and then we have another 9y, so it's 9y cubed. Let's see if that's the right answer. Don't know if it's easier than what we've done earlier, but it is pretty straightforward. Yep, and let's see, is that how Newton did it? Somehow Newton gets the easier answers. So we got up to here the same way, and then we differentiate this quotient rule. How do they go from here? Oh, they just like, yeah, they're really trying hard to simplify it, which we don't have to. So anyway, we got the right answer. All right, we have another. So we have 6x to the fifth plus 9y to the fifth equals to negative 3xy. Looking for the slope of the tangent line at point negative 1, 1. Let's play this game. Let's just try to guess it. I think that's a good exercise. I shouldn't have erased everything. We have 6x to the 5 plus 9y to the 5 is equal to negative 3xy. Looks like, ooh, looks pretty. It's not a function, but around the point of interest, negative 1, 1, it is a function. So let's just acknowledge that. So right here, it is a function, and we're looking for x minus negative 1 here, y minus 1, and we can try to guess the slope, right? So let's just use it as a slider. So what do you think the slope is? It looks like the slope is about negative 4/5, something like this, right? That's kind of the answer. Let's try to figure this out analytically. So we're going to differentiate both sides of this equation. On the left side we have 30x to the power 4 plus 45y to the power 4 times y prime. On the right side we have a product rule, so it's negative 3 derivative of x times y minus 3x times derivative of y, which is y prime. And remember, since the goal here is not to isolate y prime and write y prime explicitly as a function of x and y, we're just going to replace x with negative 1 and y with 1. And solve for y prime. So here we have 30 plus 45y prime is equal to negative 3 plus 3y prime. So 42y prime is equal to negative 33. So y prime is equal to negative 33 over 42. Everything has 3, so negative 11 over 13. Let's see if negative 11 over 13. Yeah, so you see how we got this. We knew what the answer was approximately. We just used the implicit differentiation to figure out the exact answer. Great. Is it 14? Simple mistakes like this are inevitable. Looks like that's even better guess, right? So anyway, let's fix the answer. Hey. Again, implicit differentiation basically says differentiate both sides. From there, it's just a matter of you being able to apply all the differentiation rules, with the chain rule being almost necessary. Not almost, absolutely necessary. Every time you differentiate something that contains y. So here we do the chain rule, so it's 1 over 2 square root of xy times the derivative of xy, which is y plus xy prime. That's just the left hand side. On the right side we have derivative of negative 2, 0, plus derivative of the product, so it's derivative of y times x cubed plus y times 3x squared. And in this case we need the expression for y prime, so we need to isolate y prime, which is just an extra step, but let's distribute everything over. So we have y over 2 square root of xy minus x plus xy prime over 2 square root of xy. On the right side we have x cubed y prime plus 3x squared y. We collect all the y primes on one side, so xy prime over 2 square root of xy minus x cubed y prime on the left, and on the right we'll put 3x squared y minus y over 2 square root of xy. And now we can factor out y prime here, so I can remove it here. And we can divide both sides by the coefficient of y prime to isolate y prime. And this is not pretty, but you rarely expect anything pretty in real life, so it is what it is. And of course we can simplify it further by maybe writing it as a single fraction with a single numerator and single denominator, but that's not the purpose of this exercise, so let's not do that. Why am I not surprised? Oh, because I inputted it wrong. That's why I'm not surprised. Hopefully this is a better answer. Yay. And there's a smiley face that says your hard work is paying off. Absolutely. Your hard work will be paying off. Let's continue. While it's loading. Oh, it's loaded already. So again, all implicit differentiation problems are pretty similar. Differentiate both sides. On the right side we get 0. On the left side we use the linearity first. So we have 6 2/3, so 6 times 2/3 x to the power negative 1/3. Here we have 3y to the negative 4. So this is what we have. And we're going to use the power rule. So this is just a thought here. So this goes here. And y prime, we're going to find y prime by isolating y prime on one side and everything else on the other side. So in this case it's just this. That's the final answer. This is where we have to carefully check our work. Not sure where the negative came from. I think it's just positive. So let's try again. Yeah. So making mistakes is something that you will be doing a lot. So you need to learn how to react to your own mistakes, and instead of panicking or getting frustrated, just figure out the plan, and whatever your plan is, just execute it calmly, and try not to make that mistake ever again. Differentiate both sides. Here we have 14x, 14y, but this is a function, so it's times y prime. Minus 10y prime is equal to 0. Again, everything that has y prime stays here, and we take out y prime. Everything that doesn't have y prime moves to the right side, and then we isolate y prime by dividing everything by its coefficient. And here we can of course reduce it by a factor of -2, so 7x over 7y plus 5. Of course, we have to be able to do all the same tasks with trigonometric functions as well, as they're not special at all. So we have 3 cosine 2x sine 3y squared 1 minus 5x. We differentiate both sides. On the right side we have negative 5. On the left side we have quite a lot going on. We have a product. So first of all, I'm going to take out this 3, and we have a product. So we have derivative of cosine, which is negative sine of 2x times derivative of 2x, which is 2, times the function here, plus, now we have cosine of 2x times derivative of sine of 3y squared, which is cosine of 3y squared, multiplied by derivative of 3y squared, which is 6y times y prime. And all that is equal to negative 5. Now to isolate y prime, we're going to divide everything by 3. We're going to subtract the first term from both sides. And then we're going to divide everything by this coefficient right here. It's not pretty, but it is what it is. And we got it. And some problems are easier than others, but in Calculus 2, we all treat them equally. We don't care, really. We should be prepared for any problem. And same thing, differentiate both sides. Here on the left side we have the chain rule, so 3 times what's inside to the power 2 times derivative of what's inside. And on the right side we have negative 2x minus 20y times y prime. And we have to isolate the y prime here. The easiest way to distribute everything and combine like terms. So we're going to distribute this to negative 8. So we have negative 24, negative 8x minus 2y squared, minus 6, negative 8x minus 2y squared times y prime. And I'm going to just copy this, negative 2x minus 20y y prime. And now we're going to bring all the y primes to the left. So 20y times y prime minus 6 times negative 8x minus 2y squared y prime. And we're going to bring everything that doesn't have y prime on the right side. So 24 negative 8x minus 2y squared minus. And we're going to take out y prime we're going to factor it out and divide both sides by that coefficient. So we have 24 negative 8x minus 2y squared minus 2x divided by 20y minus 6 times negative 8x minus 2y squared. And like I said many times before, it's not pretty, but it is what it is. Negative 8x minus 2y squared minus 2x, 20y minus 6 to the power negative 8x minus 2y squared. Let's continue. Another one. Differentiate both sides. On the left side we have 3 times 1/4 x to the power negative 3/4 plus 2 times 2/3 y to the power negative 1/3 times y prime. All that is equal to 0. And we're going to isolate y prime by subtracting the term that doesn't have y prime from both sides and then dividing by the coefficient. So here it's important not to mess up the fraction. So we have negative 9/16. We have y to the power 1/3 in the numerator and x to the power 3/4 in the denominator. And hopefully that progress bar is moving along, as we don't have much time left. My hard drive is filling up with these recordings, and I only have 15 minutes left here, so I'm going to try and hurry up. Again, derivative of both sides, chain rule, linearity, and here the y prime is equal to negative 8x cubed divided by 28y cubed. Oh no. Second derivative. So second derivative is equal to, by the quotient rule, derivative of negative 8x cubed times the denominator minus the negative 8x cubed times the derivative of the denominator, which is 84y squared y prime divided by 28y cubed squared, but instead of y prime I'm going to plug in our answer for y prime. So let me just copy this. This is my y prime, and I'm going to start with the denominator, 28y cubed squared, and in the numerator we have negative 24x squared times 28y cubed minus negative 8x cubed times 84y squared times the first derivative. Of course, Newton's answer would be much prettier than our guess. Let's see where we went wrong. Oh, there was no negative here. So that was a terrible mistake, honestly. There was no negative, so this is positive, this is positive, and the answer would be pretty much what we had, but with a few different signs. So let's not get distracted by this, and let's continue. So differentiating both sides, we have negative 21x squared plus 15y squared y prime equals to 0. Y prime is equal to 21x squared divided by 15y squared. Then reducing it by 3, 7x squared divided by 5y squared. Let's differentiate it again. So second derivative will be obtained by differentiating this. So it's derivative of 7x squared, so it's 14x times 5y squared minus 7x squared times 10y y prime, but y prime is 7x squared over 5y squared, and all that divided by the 5y squared squared. So this is my denominator, and we have 70xy squared minus, I'm not going to try to simplify it, so let's just go 70x squared y times 7x squared divided by 5y squared, and that's it. We really need to see the light at the end of the tunnel here before I run out of space on my hard drive. Square root of xy equals 1 plus x squared y cube, differentiating both sides, 1 over 2 square root of xy times derivative of xy, so it's derivative of x, which is 1 times y plus xy prime is equal to derivative of 1, 0 times the product rule, 2xy cubed plus x squared times 3y squared y prime. And we need to isolate y prime, and there are a couple ways here to go about this. We can distribute this, or we can actually multiply both sides by that denominator, so we'll end up with something like this. And then we can combine all the y primes here. So this becomes 6, all that y prime, and this becomes 4x y cubed square root of xy minus y. So y prime is equal to 4xy cubed square root of xy minus y divided by x minus 6 x squared y squared square root of xy. Hopefully this will give us like a little boost in progress. 4xy to the power 3 xy, let's just copy that, minus y divided by x minus 6x squared y squared, Control V, done. On the left side we have the product, on the right side we also have a product, so derivative of y times cosine of 2x minus 4y, plus or minus we have y times the sine of 2x minus 4y, but by the chain rule we multiply by that 2 minus 4y prime. That's the left hand side, and the right hand side is simply negative 2y plus xy prime. And we need to isolate the y prime here. So let's collect all the terms that have y prime on the left. So cosine of 2x minus 4y. Here we also have this negative 4 times this negative y, so it's going to be plus 4y sine of 2x minus 4y. And then we're going to have this also, y prime, so it's going to be plus 2x. That's what we collected on the left side. Now on the right side we have this negative 2y, and we have this times this plus 2y sine of 2x minus 4y. So y prime will simply be equal to this divided by this. I'm not going to write it, I'm just going to start typing it because that's very time consuming. 2y plus 2y sine of 2x minus 4y, cosine of 2x minus 4y plus 4y times sine 2x minus 4y plus 2x. Yay, we got one more objective. Six x to the power 5 plus 6y to the power 4 is equal to negative 45xy. We're looking at the point negative 1, 2. Differentiate both sides. We got 30x to the 4 plus 24y cubed y prime is equal to negative 45x plus, derivative of x times y plus x y prime. Again, isolating, so collecting all the y primes on one side, plus 45x y prime, and everything on the other side. So we're going to have negative 45y minus 30x to the 4. So we're going to factor out y prime and divide this by this. That's going to be the answer. Oh no, we have to evaluate it at negative 1 and 2. So y prime evaluated at negative 1, 2 is going to be equal to this evaluated at negative 1, 2. And divided by 24y plus 45x. Alright, so for that I'm going to be using Desmos. I'm not doing this by hand, although I can. minus 40 over 49. Hopefully that's the right answer. Yay! And hopefully the last problem. Hopefully by now you got the idea or a refresher of implicit differentiation. Hopefully you got through your homework in no time. Again, 10x to the 4 plus 12y squared y prime equals to negative 15 y plus xy prime. And we're going to just plug in negative 1 for x and 2 for y. And we got 10 plus 48y prime is equal to negative 15, 2 minus y prime. So, oh boy, need to distribute, need to collect all the y primes on the left, 33y prime. Let's collect everything else on the right. So y prime is equal to negative 40 over 33. Better be done. Yay, and I'm about to run out of memory in my hard drive, so this is how we do implicit differentiation. Hopefully you were able to handle it. If you have any questions, feel free to reach out.